Welcome back, everybody, to the second edition of Hope. I hope you had a nice and relaxing lunch break. For the ones of you that weren't there in the morning, my name is Marius, and I'm the assistant curator of the conference. Once again, together with my team of Play On, we prepared an exciting program with more than 25 speakers from all over the world to discover theater throughout new digital methods and innovations. We'll have another interesting panel about tracking and robotics in a few minutes, but before we continue, we have a few minutes left where I can show you some technical instructions so that you feel comfortable on our conference platform, Reaction Link. First of all, if you are watching via Reaction Link, you see on the right an interaction bar next to the stream. On the bottom of this interaction bar, you see different symbols. There you can react with emojis or ask questions for the panel discussion. Your questions will be included by the moderator by Q&A later. If you are watching on the website of Play On or Nachtkritik, you can't use these features. So if you have any questions, you can switch to the conference platform Reaction Link through the link on our website. The registration is free. Above the stream, you find the schedule for the next 3 days and the list of all the speakers. There you can get a little more information about the talks, the speakers, and the partners of our Play On network. If the stream is not working or frozen, please refresh the website first. If this is not working or you have any other problem, feel free to let us know through the ask symbol on the interaction bar, right? Or via mail by hope@play-1.eu. On the right, you find the info bar. There you can find an alternative stream if the one on the Reaction Link is not working. The whole conference will be recorded so that you can watch all the panels afterwards later on our website, Play On. That's all for me now. Try out these nice features on the platform, grab a drink and relax as we're looking forward to an inspiring, nice panel 3 of Hope2022. Yeah, we'll see you again tomorrow. And now it's my pleasure to introduce to you the moderator for today, Lucy Hammond.
Hello, and thank you so much, Marius. Hi, everybody, and welcome back. Just as Marius said, if you weren't here this morning, my name's Lucy, and I'm the moderator for today at the Hope Conference. Already today, we've heard from the Play On partners about their most recent projects, and also from a range of artists and technologists working with audio. We already had a sneak peek from a team in Japan about the use of robotics and tracking in performance, and now we're going to continue exploring this theme. But first, we have a small teaser for one of our workshops tomorrow from Claudius Lanzzeroni, so I'm going to hand over to you, Claudius.
Okay, can you hear me? Is the sound working? Good. Hi everybody. I just want to show you a little bit of my setup, which going to show you on Wednesday. I have a sensor system. It's a sensor system which is very easy for people to do in workshops. I didn't invent it by myself. I just put bits and pieces together, and you can see it here on my second camera. For example, there's software I can show you where you have like a tracking system, and you can in the tracking system you can start sounds and have these Zeklaki boxes here. I'm gonna show you these boxes. They have they look a little bit complicated, but they're very easy because they are like Eurorack modules. I just put together different Eurorack modules and put them together with some cables, so you're able to track your movement of your body with the sensors, and with the Eurorack system, I'm going to show you how it works. And the same system, just I put together a small system which has like the only 3 parts, and like sensor system and the sampler, which you can just get if you are into Eurorack. It's very cheap. And here's a mixer, and we go out there. And I show you how these modules works, and I show you how the system. this is one of my performances on Wednesday. So I had still the effect module on. This was the feedback. And with the sensors here, you can then with your body, you can then play with the sampler. And I show you the whole setup. I will explain you everything, and I will also go through like the process, how you combine these things. And there's this little Cyclaki, which is like only 3 modules, and the big Cyclaki, which you can use in big theater productions, where you have also the tracking of the stage with the camera. This is a system where you have to pay the software for, but it's also there, it's on the market. So it was like a project I did at school here at Ars University, because the physical theater and the actors and the improvisation musicians, they wanted to have a system where they don't have to think about the technique. You know, that was the most important part. They want to just play and have like ideas to put that in their story, and they don't want to have a software engineer beside them, and they don't want to think about the whole thing. And we talked a lot with them, and then I found out that there are so many interesting modules on the market which are made for people using it very simple, that if you put these modules together, you have a quite interesting system already. You don't have to invent something new. And so we combine these different things. And I show you how it's going to work, and I make you a little demonstration. Like I put a setup where you can see like 1 or 2 different things, just to get a feeling.
Brilliant. Thank you so much for showing us, and I'm already loving the different camera angles that we had from you there, so I'm sure the workshop will be really fascinating, being able to see the tools that you're working with. So thank you so much for giving us a sneak peek into the workshop tomorrow.
Yeah. See you.
Thank you. See you tomorrow. So, yes, I am now delighted to introduce our keynote speaker, Juergen Hagler. Juergen is an academic researcher and curator working at the interface of animation, games, and media art. His talk today will explore animating participants in co-located, playful, mixed reality installations. Sounds really exciting. So, I believe we're actually going to play the talk as a video. So, here we go. Juergen Hagler.
Hello, everybody. Thanks for this very nice invitation. Many thanks to the PlayOn team, and in particular to Sven and Dirk. It's a great pleasure to be with you, unfortunately only remote. My name is Juergen Hagler. I am a professor at the University of Applied Sciences Upper Austria, Hagenberg campus. And in this presentation, I will give you a brief overview of the things we, the research group, Playful Interactive Environments, did in the last years. Let me briefly introduce myself. I've been involved in the activities at Ars Electronica over 25 years already in a series of functions. I started as a researcher at the R&D facility, Ars Electronica Future Lab, in the mid-1990s. This image from the Ars Electronica archive shows me in the background, and in the foreground, Dan Sendin, a computer graphics pioneer, one of the inventors of the VR environment called Cave. So I had this great privilege to work with the system that Dan Sendin and his team developed, because Ars Electronica Center, the museum that was established in 1996, featured one cave system in the museum, and this was the first cave system in the public space. So since 2014, I am also the co-head of the research group Playful Interactive Environments. So besides of other research projects, the research group Playful Interactive Environment developed various playful co-located installations for Ars Electronica Deep Space in the last 10 years. So what is actually the topic of this presentation in a nutshell? Based on installations, the so-called Pi deck, and also the invisible wall installation and current deep space projects that the Pi lab developed, I will discuss novel approaches and design implications of animating the participants and also passers-by in hybrid virtual worlds. The key challenges are merging the real and the virtual world through animation, visually embedding the participant in the virtual environment, and using participants as an input for interaction for animation. In detail, we focused on this problem area by finding answers to some questions. How can actors and VR players be visualized? And how can actors serve as an input for animation in co-located playful mixed reality installations? First, what are co-located playful interactions, mixed reality installations? Of course, advanced technologies such as position tracking and motion capture allow the inclusion of multiple participants in mixed reality settings. For instance, connecting the VR user with other participants located in real physical space. What is co-located interaction in detail in the context of animation play? Regarding to Descartes et al. 2008, co-located play can be generally understood as playing together at the same space. Social interaction in real and tangible worlds between multiple actors and multiple player roles. So different roles of players, of users, and bringing these different roles together. When we look at the state of the art, we can quickly see that augmented virtuality installations for multiple players are not new. In 1998, for instance, Worldskin, a cave installation exhibited at Ars Electronica, at the Ars Electronica Festival. This installation was designed as a photographic safari into a land of war. The installation provides 3 physical cameras hanging from the ceiling and allows a limited physical co-located interaction with up to 4 people in different roles. So we see one actor who is navigating through the environment, and there are additional 3 individuals with a real photo camera, and they can take photos in the virtual environment. Whatever these users photograph turn into a white space in the virtual environment. So they can literally erase the textures from the virtual environment. So we see this first iteration of cave installations as the beginning of co-located interaction. In 2009, Ars Electronica developed a new cave-like system called Deep Space. It features a floor and a wall 8K projection surface measuring 16 meters in width and 9 meters in height. Deep Space is designed for various applications, for single and multi-user experiences, co-located games, VR installations, performances, concerts, etc. This setup offers also a lot of immersive technology, for instance, 2D position tracking system that was developed by the Future Lab. You can see these laser ranges, 2D laser ranges, highlighted green at the bottom. So for this space, for this size, up to 6 laser ranges are needed for a precise position tracking for up to 30 and more people. Since 2011, the research group Playful Interactive Environments develops various co-located games and installation for deep space using position tracking system, so these laser rangers. These installations allow a much larger number of participants to control interactive applications collaboratively. So one example that you see here is the so-called Game Changer suite developed in 2014. It's a collection of 6 games. All these games scale fairly well. They can be played equally just by 2 participants or occasionally up to 30 people at deep space. In this video, you see a further application, a co-located prototype with mobile phones tracked by the position tracking system. So the users can use their mobile phone as an additional input device. So these developments led us to a basic interactive setup for public spaces that we have named Playful Interactive Environment Deck, in short PIDEC. This is an interactive installation setup. This allows a co-located interaction for up to 30 people, depending on the size of the interaction space. So the interaction space is up to 150 square meters. So if we are using 6 laser rangers. Optional, of course, with projection, plus the integration of mobile devices, as I've shown you already, and also mobile VR headsets. So in this case, we used Samsung Gear VR as an input device. The second example, called Invisible Walls, is an improvement of PIDEC. It is an experimental augmented virtuality interaction space. So augmented virtuality, bringing real space and the virtual space together. And this interaction space was exhibited at the Vienna Design Week in 2016. For the VR player role, we used the HTC Vive that allowed us to create complex visuals and provided a full room scale position tracking head and hand tracking, which was achieved by the Leap Motion device that is attached in the front of the VR device. So we had a room scale tracking, a hand tracking, and in addition, the 2D position tracking. The installation consists of a large scale projection, a VR headset that supports hand and finger motion as input, and the laser position tracking system. The physical interaction space is about 40 square meters. As shown in this video, spectators are represented as 3D sculptures moving in sync with the real location of the players in the physical world. So we used the 2D information to move these 3D sculptures. The invisible wall is indicated via a LED light. How did the VR players get in contact with the spectators? Via their hands, VR players could change the color and shape of the spectator's representation. So touch and finger gestures were served as the connecting element between the spectators and the players. These 2 videos show the 2 view modes of the installation that were displayed on the projection screen behind the VR player. The spectator's view on the left side served as an idle mode of the installation and should encourage visitors and passers-by to participate. When an interaction phase started, we switched to the VR view, which is the current viewport of the VR player and which should serve as a mirror between the virtual and the real world. During the development phase, several design issues had to be solved. So first, one major challenge was to properly divide the interaction space between VR user and participants while simultaneously avoiding potential collision. So this was a finding that we got from the prototype in Zagreb. Another challenge was the visual representation and the animation of the participants' avatars. During the evaluation process, a majority of subjects reported having a positive impression regarding the abstract visual representation and also the limited abstract animation. The third prototype, called Cargo, was developed specifically for Ars Electronica Center Deep Space and was designed to integrate multiple VR players, several non-VR players, and a large live audience into a shared co-located mixed reality game. In the game, 2 VR players control a spaceship on its way to deliver supplies to a remote space station. So that was the mission. Spectators can also join the action by entering the tracking space and becoming collective drones that accompany the spaceship on the way to its destination. So overall, there are 2 VR players, yellow, wearing mobile VR headsets, and these 2 players can steer and define their spaceship using their physical location and head orientation. With the tracked position of each player's physical body, the robot avatars can be animated to visualize their current focus and task seen on the VR overview. Non-VR players, red, are also tracked and visualized as drones in the virtual environment. The large screen on the front projection provides the 2 VR views, blue, and an overview including the 2 VR player. Cargo demonstrates that even fairly large-scale co-located mixed reality installations are feasible and that participant-based avatar animation is essential for creating a shared playful experience, different roles, different animations, different representations. So a brief overview of approaches for how participants can be animated in a playful mixed reality setting. First, we recommend a basic and a robust form of motion capture systems, so like the laser rangers at deep space. Due to the technical limitations, participants in the PI deck were visualized via simple forms along with a limited animation approach. In the installation Invisible Walls, a more elaborated version of the participants' representation and animation was chosen. Furthermore, the VR users could alter the animations by getting in contact with the participants, which also had a positive impact on the perceived co-presence. In the game installation Cargo, the visual concept was driven by the different player roles and the visualization and animation of the VR players and co-players can foster the collaborative gameplay as well. In conclusion, we argue that our approach revealed several interesting findings in this context. To avoid too high expectations amongst participants towards the visual fidelity of their representations, it is recommended to keep the design of the avatars simple and abstract. In all of the case studies, the abstract visualization and the limited animation was perceived positively. One key challenge was to create a design that communicates a consistent and visual look and feel for both the VR user and the participants. Due to the limitations of the interaction devices and their roles in the virtual environment, the VR user and the participants had to be shown in different ways. In example, in Invisible Walls, the VR users' hands are shown while the participants were displayed as an abstract human motion form. So for future work, we have planned, of course, to investigate different settings, different public spaces, also different interaction channels. We did already some research on gaze interaction, body interaction, and also animation inputs like motion capture, suits, etc. Thank you so much.
Thank you so much, Juergen. And Juergen will be joining us for the panel at the end of this session. So if you have any questions, please do let us know via the reaction link. And yes, we look forward to hearing from him later. So on to the next. We're going to hear now from pioneering artists Silke and Amir, who together have been exploring the world of dance and robotics. I'm really excited to hear about your project. So thank you so much for joining us, and take it away.
So I remember myself when I was standing the first time at the Gleishalle at the Ars Electronica Festival, standing in front of this 3.5-ton KUKA roboter. And I was saying, oh my God, is this gonna be my new performer, or this is gonna be an obstacle for me? But Johannes Braumann took all my fear away, because I asked him, give me a list of things that I'm not allowed to do with this. And he kept on going and telling me, okay, these are the things, and this you can do, and this you should not do, and so on. And we had very little of time to did a choreography with the Orchester and with Cory Orlan and the conductor Markus Poschner. So I was facing more or less the situation of, you have this robotic arm that through movement gives you meaning, right? So in connection with performers on stage, you have to try to find a way to build choreography that is not only flirting with technology. So we built this situation that we could, of course, take all the favors of the robotic arm in terms of we could hang on it. It was very precise in terms of as a choreography partner. And in the end of the day, it was really for me decoding this movement of the robotic arm. There was also parts in it where it was just going on real time with the Orchester when it was playing the Berlioz symphony. But yeah, that was kind of like our first encounter. Then a year later, in 2019, again, Johannes approached me with this very unique idea of taking the super KUKA, as I call it. It was one robotic arm with like 4 little KUKA robots mounted on it. And this approach was different already to the first one. It was like having a pas de deux with yourself. So we captured all the way of how I would dance in a solo. And then we transferred this onto kind of like the big KUKA robot with the little ones on top that would puppet master some sort of a skeleton. And this skeleton would be an abstract version movement of myself. And I could have really this possibility of interacting with myself. So that brought me to the whole choreographic approach of how to transfer choreography or the intention of a performer through this intangible interface onto another body. So having the idea of being on one part of the world and dancing a duet with someone completely different, but having this transferring situation. So yeah, of course, the next step had to be done. And now Amir came into the game with also the spot from Boston Dynamics. And here I would say we are now in a way trying to think more in a choreographic way of how can you interact on stage without being only the presence in its own of the performer, but also the presence of the robotic. And you know, he looks like a dog. So we have already lots of things that we already implement on it, or that we as an audience expect that they should happen. So in my work before with Silke and Silke Flügge, I always tried to bring 2 things together, and I have to more or less steal a term from programming, and that's high level and low level. So in terms of you choreograph a performance piece, you try to, in a way, bring everything together that it's very approachable for a lot of people. But in the same time, in the low level, we wanted to try now with split subject to also reveal another side. So that like the audience who is like a professional in seeing contemporary performances or also programmers would have a possibility to relate to it. So I think the aim is now working in choreography for us to find a way to bring these two things together, that they can connect. And here you're gonna see a little thing that we're working on now.
What angle you are to the head of the robot, right? Think about yourself.
Yeah, so when we bring a robot on a stage, automatically it becomes this external entity which demands interaction. You cannot simply think of it as part of the props or another performer, that they work together and communicate as a body. There is this invisible force that wants you to interact with it, or there is this invisible force that some cases wants to see somebody interact with it. Now, before diving deeper, I would like to declare some words here. What I mean by interactivity. So let's think of when we interact with a gadget. In this case, when we interact with a robot, we could say we are not interacting with the robot itself, but we are interacting with the computer that controls the robot. And of course, one can argue truly that we are not interacting with the computer, but with the program that has been executed on this computer. Of course, we have to acknowledge that there is a programmer writing a program, putting it on a computer, and the computer controlling a robot. So what is important here is that the programmer, of course, I don't want to go down this way. There are programs that they can write programs or dynamic decision-making situations, complex state machines. Let's forget about that. And for the sake of this conversation, keep things a little simple. There is one programmer and there is one user. And these two, they share one area of intention. And that intention is, so to say, to be the purpose of that interaction scenario. Now, we are safe to say now saying that when we interact with something, indeed, we are interacting with sets of procedures in a sequence of order that define a narrative. To get there with that narrative, we can reach the purpose. So simplifying again, whenever we interact with something, actually we interact with a narrative, not with that thing itself. Now, when I started working with Spot almost a year ago, of course, there are these narratives around the Spot. I had no idea how does it work. I didn't even know how to turn it on, how to use it with the controller or with the API and so on and so forth. So it was this chance and luxury to just dive into it and learn how to do that. Back then, I was trying to start with this utility I'm working with for my own practice called Bonrako project. It's a real-time tool that you can control robots in real time in the Creative Robotics Lab. And I thought that it would be good to include the Spot in there as well. And during this process, I could not, it wasn't the second I could forget about this beautiful piece, this performance, I like America and America likes me. So what is happening there when we think of it from this definition or declaration of interactivity when we talked about? When the artist enters to this void, let's call it the gallery space, and locks himself with a void animal that we have no idea what it is, what is happening there is an interaction with this external entity that we use to watch this narrative, or we use to basically demand this interaction that one other person has with an external entity. We are looking into an imaginary state. Later on, I'll tell you what do I mean by this imaginary. But thinking about boys, of course, putting a spot next to it, I approached Silke. I'm like, hey, are you up for doing something with a spot? And luckily she was like, yeah, let's get into it. And we both had this idea that it's good that this project happened before this I Like America and America Likes Me, because we don't need to talk about a few things that is already done. We are just referencing, we are addressing to the masters. But if we move forward from the boys and addressing to the I Like America and America Likes Me, I would like to talk about subjectivity in Lacanian psychoanalysis. Of course, I don't want to get deep into it. I could not resist not to show this graph. What we see on the screen is the conceptual vocabulary Jacques Lacan developed for his psychoanalysis exploration. So what is happening there? We have this S1 and S2. We don't want to know what they are. S1 stands for the master signifier. So the master signifier sort of evokes or snaps or weave some other signifier together, and things that start making sense, right? The production of this making sense situation is to produce the subject. But there is one thing that is actually what we want to pinch. The problem with subject is this is not something that it can repress itself. I have an example. It's one of the jokes that Zizek has in one of his books. If I'm not mistaken, is Less Than Nothing is the name of the book. He says there are two people go to a theater and they are sitting there. The theater is boring. They are not really connecting with that. And one of them says that, man, I have to go out and use the bathroom. Do you know where the bathroom is? And the other's like, I don't know, just get out and find your way. He goes out of the theater. He's stressed. He wants to find the way. It's dark. He goes to a corridor, down the way, gets lost, sees a door, enters. The room looks like a private room. Nobody's watching. He sees a flower pot, takes the flower pot and pees inside the flower pot. No one's watching, puts it back and comes back to the theater. The moment he returns to the seat, his friend says that, man, you missed the funniest bit of the theater. A random idiot just walked on the stage and peed into the flower pot. That very moment when you want to make sense of these two external signifier, this very delay, this fragment of a second, before you build this knowledge is the subject itself, as Lacan suggests. Now, as I said, I don't want to really dig into this very Lacanian psychoanalysis. Of course, there is no time, and I am not qualified, of course, to talk about it. But that is part of the concept we are developing for a split subject. Indeed, we are sort of trying to suggest the very attraction of us to interact with robots or interact with these other silicon entities is itself failure, because the moment you start to acknowledge them as an external entity, you fail. You know, like there is this language joke. Of course, German speaking, they know that in German you call the robot a he, right? And the moment every time people are there, every single of them, they say, can we call it a he or a she or what? In the beginning, I was conservative. I was saying that no, it has to be a it. And then I realized no matter how much we try to give it its own characteristic or trying to put it in a signifier, it fails. And that failure itself, indeed, is through the process of interactivity, is the subject. Now, of course, for working with the spot, we had to develop our own software. I was working on Bonracco, and of course, thanks to Johannes for his knowledge and support, I developed this dynamic tool that now I need to shout out to Capture, the dog owners, the company that they, I'm super happy that they let us use their robot whenever we want. Now we have, using their API from Boston Dynamics, we have a software that through that software, we could create timeline in real time, and we could implement simple state machine. And what is happening in this performance is not that we entirely controlling the robot. And of course, I'm not saying that the robot is autonomous, but we have different modes, and according to the situation of the theater, according to the tracking data we receive from Silke's performance and behavior, we demand the robot to do certain things or behave in certain things. What you see in the slide is the VL, is VVVV gamma. It's the VL language that we are basically developing this software over there. That would be it from my side. I would pass the stage to Silke.
Thank you, Amir. So yeah, now we had kind of a trouble since 2018 working with these entities and these possibilities. And now, of course, we were always in a secure, like in a protected, secure space. And now we, of course, we are approaching, or we want to go into the direction, what would be if it's not a theater space? What if it's a public space? what happens if we cannot have like the live tracking on spot? Like, what is it? There's a beautiful word for it in German. It's called the Zufall. So you cannot really translate it in English, but by chance, what happens by chance? So of course, we're also very interested in the next part. So now we're gonna finish split subjects, and then we're gonna keep on walking a little bit more outside. So thank you for listening and seeing us, and hope to see you.
Brilliant. Thank you so much. That was so fascinating to see how the complexities actually of the interaction between dance and robotics kind of work, and all those kind of blurred spaces where the interaction has different kind of I don't know, messages or ways of kind of speaking to an audience. I think that's really fascinating. Thank you so much. Now for our next speaker, it's my pleasure to introduce Johannes Brouwen, Professor for Creative Robotics at UFG Linz, leading an interdisciplinary team of researchers towards exploring robots as an interface between the digital and physical world. So it's the perfect follow-on really from this last project. So a huge welcome to Johannes. I'll hand over to you.
Thank you so much. So yeah, you already mentioned it. I think the key term really is this interdisciplinarity, and there's the fun part in working in interdisciplinary teams is that you often switch roles. So very often I'm in a kind of creative person in a very technological environment, and today I'm super happy to be the technical person in a very creative environment. So this is just part of the fun. The topic of my talk today is getting started with robotics, to look into how we can work with robotic arms. So today we're just seeing more and more of those robotic arms in installation and performances. So I wanted to give you a quick overview of the challenges of working with those large-scale machines. I mean, those robotic arms are also referred to as industrial robots. They originate from the automotive industry. The approach, both in the automotive industry, but also now increasingly in the creative industry, is that it's more efficient to use a universal machine than building your own custom machinery, where you need to deal with all those interdisciplinary challenges you see on the left side. So a robot has so many different parts and components, it's very hard to do that just by yourself. In previous research, we have realized dance installations for the Expo, for example, in Dubai. So this was actually voted as the best performance for what I saw recently at the beginning of April. And we've also created stage shows with several robots playing an electronic guitar. You already saw the projects that we collaborated with Silke and the Ars Electronica Festival on in the previous presentation. The nice thing here is really this kind of geographical proximity, that we have this super interesting network and super interesting facilities and super interesting people, of course, that we're able to work with. And with Spot, we're now also moving beyond robotic arms towards new machines. So this is also very exciting for us. My presentation today, however, as I mentioned, is more technical. So the goal is really to introduce you what it means in practice to work with those machines in a context that they're not really made for. Let's start pretty boringly, but importantly, with costs. So what are we talking about? How much does such a machine cost? Well, a small robot starts at around 20,000 euros. And besides, in this case, feeding babies for the Bavarian Broadcasting Company, you can also do many other things, and all of that in a very, very fast way. So the focus of those machines is really speed. We can program both small and large robots the exactly same way, but large robots can simply move more payload, and they've got a larger reach. And of course, for that, a quite different presence on stage. They usually cost around 50,000 euros upwards. What's interesting is that there's a rather large used market for those machines, as enterprises often discard robots before they've reached the end of their life cycle. So this then really makes machines accessible to individual artists, even groups and theaters, hopefully, as well. What's important to remember is that you usually just get the robotic arm without any tool in front or any advanced programming software or whatever. And this is a key factor, that the robot itself is not intelligent. It does not have any intelligence or artificial intelligence, but it simply does what you program it to do. So any intelligence has to come really from its program. Often you have people who expect these machines to be very kind of intuitive and collaborative because they're called maybe collaborative robots in some cases, but actually they're machines that do pretty precisely what you tell them to do. So what happens once you get a robot? Let's look a little bit into logistics. A large robot can cover a volume of over 55 cubic meters. So they are in practice pretty huge machines. Fortunately, they can be folded down to a much smaller size, so they can actually fit through most doors, like here at the University for Applied Arts in Vienna, where we collaborated on a project. However, the robot, as you saw, is not exactly light. The machine itself weighs 1.1 tons, but it can actually exert a vertical force at full speed of up to 24 kilonewtons. So this is the equivalent of around 2.5 tons. So there's quite a lot of force that goes into the floor. Ideally, you would just bolt the robot down into concrete, like we did here for the Ars Electronica Festival, where we're working in an industrial environment where doing so was not a problem. In many environments, of course, that is a much bigger problem. So then you need to build a heavy platform. How heavy that platform has to be basically depends on how quick the robot has to move. For that project, we collaborated with the artist Davide Caiola and designed an extremely robust steel frame that cost quite a bit over 10,000 euros to make. If you move slowly, you can get by with smaller platforms. However, it's generally hard to find someone like a structural engineer who will sign off on these kind of platforms. So usually we also just have to make educated guesses and over dimension to make sure that whatever we do is actually not going to fall apart. Smaller robots are easier. They weigh around 50 kilograms, are therefore much easier to handle. Here, for example, they're simply screwed onto a wooden wall, and so far they're holding tight. So what about safety? So in the context of robotic safety is, of course, quite an important aspect, but I have to tell you that I'm not exactly a safety expert, but I can give you a rough overview. First of all, we need to acknowledge that robots are fast and strong machines, so safety itself is really an important factor. So on the right-hand side, you see a robotic arm who basically pushed itself through 2 centimeters of wood without any problems at all. So you don't want to be between a robot and a wall, for example. Legally, robots are considered incomplete machines, so they themselves do not have a CE mark. We often work with partners who are basically saying, well, if it has gotten CE, then it's fine, which unfortunately doesn't apply with those robotic arms. Getting a CE usually costs several thousand euros and only then applies to that particular setup. So once you, for example, change a robot's tool, the CE is no longer valid. So in practice, that's a problem. For example, here you can see a robot producing cotton candy. Legally, that robot should be behind a cage or light fence. The operator would then need to press a button to request access. The door would unlock once the robot has stopped moving, and only then is the operator allowed to go in order to get the cotton candy. So obviously doing so is not feasible in a performative context. Our approach is therefore to be as safe as possible. In general, unlike in industry, our installations are supervised. So for Dubai, for example, we utilized this device that you see here so that the show caller could always stop the machine if something unforeseen was about to happen. In that project, you can see a laser scanner underneath a McLaren car for a pop-up store that stops the robot when it detects a person coming too close. So while this covers most scenarios, we always have to deal with the remaining risk and therefore, unfortunately, also with the remaining liability. What about software? This is kind of our main topic, because by itself, the standard way of programming a robot is that you move it using the buttons on the controller. Then you save the current position and you repeat that process until you have a final program. The advantage of that is, of course, that you don't need a PC. You can just work on site, but at the same time, it's also not terribly efficient. So our research is also about creating interfaces so that this movement data can then come from other environments and platforms. For example, we work with the visual programming environment Grasshopper, which is popular with architects and designers and is now being applied in more and more fields of work. Here you can see how we can use the platform to connect design with production. So when the design changes, you see how the robotic fabrication changes along with it. We can also use it for more creative processes. For example, here you can see a custom notation system for the guitar playing robot that also synchronizes the 2 machines. So the idea here was that the guitar player was able to work in a graphic interface where all the programming you see on the right side, he didn't have to worry about. Yeah, so this is, whoop, there we go. Anyway, so this is where we could then simulate it and then send it to the actual robot. We can also use that system for working with other data, like, for example, motion capture data that Silke already referred to. So, for example, then we took the data from the motion capture system, we interpolated it to 250 Hertz, and then mapped it to a 5-robot system that duplicated the dancer's movement with the pretty exact timing. Internally, of whatever we do, the result of the programming process is usually robot code that looks a little bit like that. It defines motion type, speed in meters per second in that case, motion blending, and the coordinates where you want the robot to go to. Within a performative context, an important limitation is that by default, you cannot define a time like a keyframe. And the robot movement is too complex to simply say that time is equal to distance divided by speed. Therefore, doing things that are true to time can be quite challenging and needs innovative solutions. It is also important to acknowledge that a robot is not a smartphone with an easy-to-use programming interface. While everything looks quite modern, much of the technology in the background really dates back several decades. This can be the 90s, this can be even easily the 80s and further back. So here, for example, you can see a schemata for a real-time control system that was made to communicate with industrial controllers, and we had to adapt it to make it accessible to new user groups. So where does that lead us? Our projects are often the result of innovative ideas by our partners with whom we then work to realize them. However, as a university, we're not interested in locking partners into our services or whatever, but to provide knowledge transfer so that they're empowered to control robotic processes themselves. So research-wise, a significant effort in that area, a new real-time control system to realize interactive processes like you've seen, as well as the integration of new platforms such as Unity that each come with new user groups and therefore new user requirements. They also allow us to more easily interface with other technologies, like here, for example, a screen capture from our Microsoft HoloLens mixed reality headset that controls a virtual robotic arm. So the idea, of course, is that if you know how to use an environment like Unity, and we can make it easier to work with robotic arms and therefore enable these completely new types of applications. So I hope that I was able to provide you with a quick overview into robotics. I'd be happy to answer any question you might have during the panel. And you're, of course, also welcome to get in touch by email in the future if a relevant robot project pops up. So thank you very much.
Brilliant. Thank you so much, Johannes. It's actually really interesting to hear about the sort of safety issues around a machine of that size and power. Yeah, I'm really fascinated by that, but we can talk more in the panel later. So thank you so much for that contribution. That was great. We're now moving on to Krzysztof Haberko from the Copernicus Center in Warsaw, and he's going to introduce us to the acting robots of the Robot Theatre. Oh, one second, my notes have disappeared. Of the Robot Theatre, the Robotic Acting School practitioners currently have a repertoire of 2 plays, a fairy tale and a short story. I'm very intrigued by this, Krzysztof, so I'm really looking forward to this talk. I'll hand over to you.
Hello, good evening. As I'm introduced, I'm Christopher. I'm associated with Copernicus Science Center for about 4 years, and now I'm for 2.5 years maintaining and looking after exhibitions and also the theater. It is one of the oldest and one of the first theaters of this kind in Poland. It was the Copernicus Science Center was opened in 2010, and the theater was one of the first exhibitions. So now it's like 10 years of theater work, 2 years of COVID break, and it's very popular, still very popular. We know that because we had a lot of emails arriving to our information office. What will be the time where the COVID restriction will be loosened, and we will reopen our theater and play our tales for the children. As I said, the target audience are children 7-12 years old, and what else? The theater. All right. The theater is a very small space. We have a special entrance with a timetable, and it's 10 years still the same design. These are the engineered arts robot espions. This is one of the first there's designs. These are not the same we had at the opening, but the way they work and the way they interface with each other is the same. Here is a stage. It covers every electronics, every control device, which lets the robots to play their roles. The scenography is, as you have seen, it's stark. We don't have anything fixed like stiff, permanent, because we play the shows one by one. So we have to change it immediately, and the technology is helping us with that because we have spotlights, for example. These are directional spotlights. Every robot has one. So when we are trying to do some scene where there are two robots or a single robot, we can turn it off and move from the scene on the side. And the robot is also darkened. So we can have a play of a single robot or a couple, for example. The second main part is the projector. It's like a cinema projector, but it also has a tracking system, so it allows us to create a scene behind the robots, and also we can move the scene on the sides of the stage, so we can make a scene for a single robot, two robots, or everyone on the stage. The robots, as I said, they are engineered arts design. They are calling them the stars of the show. And I will show you how they can move, actually. Okay. Oh, I have a little trouble with the movie. There's a test mode. This is very important thing, because when you are turning on the theater, there are very many parts you have to check if they're all right, if the audio is okay, if the movement is okay. So every robot has a single program which inspects every type of the move. They are moving their hands, fingers, arms, which is, like, for me, they are crucial because this is a body language. They have very simple face, simple expressions. So when they are moving their hands, they are showing the audience what they are actually, and there's the mood of the robot. They have some LEDs to become a person of the character. They are different. They have different eyes on the LEDs, and also a blush, for example, on the face. So this program, this test mode, actually shows maximum amount of the movement that they can do, and every feature they can actually use on the show. With the cooperation, as the legs are not moving, they are only construction for the robots. They have something like a rail, a platform with the attachment for them. And they are moving towards each other, and they are leaning on each other and moving their heads to each other, so they can actually talk, play together. And the robots can actually be very close to each other. So we have to look after, and this sensor which detects the end of the maximum movement, so the collision will be not present during the show. These robots are run by the air, and some other parts are with the electrical engines, so they are making a lot of noise actually. We have audio system in the theater, but this natural body like we have human sounds of the body. We have steps on the stage. The robots has hissing noises, and all the mechanisms are making a lot of sounds. It's in my opinion, it's a feature, not a problem, because it's not the theater of robots, human, or not the theater of human with robots. It's a theater of only robots. In my opinion, it's like an ancient Greece when there was only a space and only 3 people who were coming back to the stage and becoming a person wearing only a mask. And the robots actually, they have a mask. They have a body which can change light. They dress like the other character. They have their faces which can have, like I said, a blush. They have different eyes pre-programmed, and so on and so on. So with this setup of features, with this setup of robots and the space, I think we can make any kind of show, any kind of play which corresponds with the topic of science, future, robots, humanoid robots, even like working with people among us, because this kind of body, this kind of ability, and this kind of, I don't know, the topic is like a glue, and it fits together like a glove. Thank you very much for this short presentation. I'm presenting you the contact for me and engineered arts, because they have many robots, and as a person who maintains them, they are very helpful because they have a Wikipedia and many things to read and watch to get better knowledge about the robots. Thank you very much.
That's brilliant. Thank you so much, Christoph, for that talk. Actors, watch out is all I'll say, having seen those robots. No, I'm joking. It's so fascinating to see. I'm really interested in that analogy to ancient Greece, actually. It's kind of really fascinating. I have a question for you for the panel later. Now I will remind everybody, please do send in your questions for our amazing speakers. If you have questions for them, please do send them in via the reaction link. We'd love to hear from you and hear what you'd like us to ask. So now we've got our final speaker, Claudio Milani. He is a storyteller whose theatre playfully combines tracking and robotics for a young audience. I can't wait to hear about your projects. So over to you, Claudio. Thank you so much.
Oh, thank you. Ciao a tutti. Hello, everybody. My name is Claudio Milani, and my English is not perfect, but I have some pictures. I am part of a small theater company named Momom. We are only 3 persons. We do theater for children aged 3 to 8, and we tell stories on stage. We have 3 different research fields. Text. New fairy tales for new children's generations with themes that are important to human beings, like fear, death, identity, integration, emotions. Stage machines. The stage machines, objects that move on stage. And last, original music. The original music written specifically for the shows. Today, I'm here to tell you about the machine we use on stage. The first thing that we do is ask ourselves a question that is linked to a magical and poetic image. For example, if you want to use a symbolic object like an helium inflated balloon, how can I move it on stage so that it goes where I want? And after that, we understand what is the best way to realize our idea. The technology applied to the scene becomes for us the way to be able to do something that is not possible in any other way. Now we can see the first video of our last show. The show is named cuore in Italian. That means heart, heart. You can play the first video, please.
E Nina, per inseguire il palloncino, entrò nel bosco anche lei.
And now you have seen the show, and we can see some moments from the backstage. You can play the second video, please.
Sì. 1, 2, 3. Sì. Posso andare? Sì.
So in this video, you saw the system that moves one helium-inflated balloon, two stepper motors that move x-axis and epsilon axis with two wire cables. The movement is completely controlled by a microprocessor that receives information from the personal computer of the technicians. All is calculated in relation to the space of the stage. When we arrive on the stage, we set the center and other parameters like height and maximum distances. After that, all the balloons are ready to dance according to the sound and music. All this is automated system is controlled by Max MSP with Ethernet OSC communication and ST microcontrollers. Max MSP controls and synchronizes the movements of the objects with the music and the lights. All is automated, and me on the stage and the technician in the control room can play together. Now, two videos about eyes and flowers. Can you show video number 3 and number 4, please? Thank you. In this case, we use simple servo motors and some LED. All is controlled by the same Max MSP program via Ethernet. I play with eyes on the scene and children love. All the mechanism is moving according to the story. My company, named Momom, continually searches for new fairy tales words and tries to put on stage symbolic elements to reach a varied audience. Technology can serve to this scope, looking for answers to the question, what can be done on stage today that once could not be done? We are a very, very small company that play theater also in very, very big theaters. This is possible only thanks to technology. Informatics applied to mechanics can make wonderful things. You have just to find an idea and try to reach it in the reality. Good luck. And in the end, I can show you some images from our other recent projects. Can you start video number 5, please? Thank you. That's all. Ciao a tutti. Thank you. Grazie.
Thank you so much, Claudio. That was really magical. What a magical way to end the day today with your lovely talk. And I feel like I would love to see your technologies on stage with your storytelling, but also just as installations. I think they are really beautiful. So thank you so much for that. Well, we are about to move on to our panel talk, but before we do that, we are going to share again the video from Theatre Ludovie, which we showed this morning. So we will share that now, and then straight afterwards, I'll invite our speakers back and we will ask the questions that you have submitted. So here we go.
Help us to make people smile. Let's help together Ukraine.
Thank you so much. That's a really important video, so I'm so glad we managed to show that. Thank you everyone for joining me again for this panel, and thank you for all your brilliant contributions. We have had lots of questions submitted, so I'm going to try and get through and make sure everyone gets their questions to them. So I'm going to start actually with a question to Juergen. Thank you so much for joining us, and thank you for your video. The question is, the person has said, you mentioned public spaces. How do you include such a system in a public space? Are there already concrete plans for this? And have you already experimented with it?
Thank you so much. Unfortunately, I'm still suffering of an infection, so I think you heard it in my presentation. The question. Actually, yeah, we had this privilege to work with the laser ranger system that the Ars Electronica Future Lab has developed, and we had this privilege to buy some laser rangers with the software at a very early stage, and our idea was bringing the laser rangers in public space, and we did this in Zagreb at an animation festival. And we immediately faced this issue that it was very tricky to track the passers-by and get attraction of the passers-by. So we immediately had a safety area to establish so that we separated or we marked the area of interaction, and even it was for us for this installation very tricky to integrate the passers-by with with the VR players. So it's much easier in a setting like a deep space at Ars Electronica, where you have a separation in this room, the interaction space and the space for the audience. So that's we haven't tried again to do this in public space actually. So that was our first and only try.
Sorry, I couldn't find my unmute button there. First time all day. Thank you so much. Yeah, I think that's really interesting, isn't it? Because it just shows that how controlled environments really do aid the complexity of that technology. And there are so many variables in public space. Even those that just do live performance without technology in public space understand this. So I feel that that makes total sense. And I really hope that that exploration continues. I'm glad that that is happening, actually. That's really exciting. So my next question actually is to Silke and the dance company. Someone's asked if there are already possibilities to feed the robots. Ooh, I think they mean feed the robots with maybe artificial intelligence, I think is the question, or give them random cues so that they can go into improvisation. Could they receive information from the dancer in real time, or is there a world in which that could happen? I'm putting that question to both you, Amir and Silke, about your experiences.
Well, I'm gonna answer first. Is this okay, Amir? Sure. Okay, good. So, of course, what we do is we try to really experiment also in the way of how, for instance, Spot reacts when I would push him. I would push him away, and he would need to kind of rearrange himself to come into a situation where is more or less like not his comfortable state, I would say. I don't really understand the question of how we feed him. I mean, in the end of the day, of course, he gets like information from my movement, how much, how far I'm away from him. We even measured it. So we can also go a little bit more in detail about this, that we kind of measured the distances between us. And of course, we also worked in Ars Electronica Deep Space. So we could track myself, and also when I would step out of the space, how he would react and so on. As we talked a lot about the presentation. I think for us, it's also the idea of how the choreography works in it. So how the expectations from the audience is to the performer, how it should react to the robot in a way. So this is kind of a very strong focus. What's also for me as a choreographer. And of course, like Amir said, like I certainly in the beginning started to refer to him or she or it. So he was right there for me, like as an entity that I would like to relate to, and I would like to create meaning, and I would like to bring this further and further and further. So of course, when I'm looking onto Spot, I'm like implementing my own wishes on him, but in the same time, there is the wish for he does it also to me, for the audience. So Amir, do you want to take over about feeding Spot?
Yeah, I think if I get it right, the simple answer is yes, you can feed a Spot. So there are two things technically speaking about it. It's like, well, we could send commands to a Spot. There are available commands that you find them on Boston Dynamics SDK, that they have it available how to use the robot. But of course, there are two main things that you come across this feeding topic. Is like, well, you could push the robot or command it that moves forward, backwards, it turns around, and so on and so forth. But it doesn't mean that it can walk. It doesn't mean that it can avoid certain areas. When I'm saying avoiding, I'm not talking about the collision detection, because the robot itself has 5 cameras around itself, and there are a few layers of programming that in the very core, the robot itself has. You can enable or disable it, that it avoids obstacles, or it walks over them, or it just avoids them, it doesn't go to the wall, it doesn't hit people, and so on. But of course, if I want to elaborate on feeding, is of course you can send position and commands to the robot, but of course you need to come up with this software or this structure of a command, that what purpose you want the robot to serve you. Of course, when I tell you just to stand up, turn around, and sit, again, you have this definition implemented to your behavior, you do them, but you cannot just tell the robot to stand up. You need to define the sequence of robotic movements that in the end, they sort of demonstrate, orchestrate this very behavior. But it has complexities. Simple answer is yes.
Great. It's good to know we can feed the robot Spot. It's like, don't want it keeling over from lack of sustenance. Anyway, I have another quick question for you guys, actually, which is, have you worked with more than one robot at the same time? And is that something you're exploring, or you have done? Is that possible?
Should I take that first? It is possible. Yeah, it is possible. So the software that we use to control the robot can feed multiple instances of the robot, of course. Technically, yes, and we are actually currently looking for the chances to use more than one robot on the stage. And there are some talks, but I would prefer to keep things and announce things when it's securely is going to happen. But yeah, that is also technically, yes, it's possible.
Brilliant. And there was one more question while we're on this mode about the secret performances. Someone did ask if there's a possibility of seeing one of your performances. Where is there a future schedule for showings?
Yeah, right now. So first, the other question, yeah, of course, ensemble work is also planned, not only duets. And the other thing is, yeah, we're working on finishing our performance now. And hopefully in June, we're gonna have a premiere, hopefully. Right, Amir?
Yeah, that's exciting. Yes, stay tuned for the, we will make sure to pass the announcement. Yeah.
Brilliant. Thank you both. I'm actually going to ask a question for Johannes now. I have two questions for you. The first one from the audience is, someone has asked, is it possible now to program a robot arm by moving it physically with our own hands to teach it how it could appropriate that movement from those steps? That's one of the questions.
Yeah, I mean, it's always a difference between technically and how it then makes sense. So this is a feature on more modern, like collaborative robots. They have sensors that can detect when they kind of hit a person. Like a normal robot would really only notice this very late when it's dangerous. So the idea of these cobots is that you can use this force as a factor, and you can also use it then to control the robot. So technically that works. But for also safety reasons, for example, that movement is still very limited in speed. So you have a certain resistance. So it would be hard to really kind of record physically a performance and then have that repeat in a kind of exciting way. We did similar experiments in a more technical sense. I remember that at one Ars Electronica Festival, we had one of these collaborative robots where you would draw something and then the robot could kind of record this and redraw it again afterwards. So as I said, technically possible, but I think it's not a great creative tool usually, because it helps you a little bit, but it's not like making everything totally accessible all of a sudden.
Yes, I can imagine actually, having seen the power that you showed us that those robots have, having that kind of physical interaction with one of those examples would be, I imagine, quite tricky actually, in a public setting especially. I have a question for you that actually is one of my questions. I wondered about the character of the robotic arm, because some of the sort of installations you showed had a product at the end in a way that the arm was creating, like the candy floss, for instance, or a drawing like you just mentioned. But the movement of like the kind of end of the arm is kind of a character in its own right. And I just wondered, have you kind of explored that and the movement of the arm in that way of storytelling in a sense of making it a character in its own way?
Yeah, I think that definitely relates to what we did with Silke with the underbody project, for example, where this was a big kind of creative factor. But I think also in general, this is something that I still experience, that it's surprising how long you can keep watching a robot do something that is fundamentally boring. That does not relate to the performances, of course, but if it's drawing something, if it's cutting something out of material, something that might take a couple hours. So the project you briefly saw with Davide Coyola, that was a 7-hour-long milling process that was going on. So there's not a lot happening, but it has this kind of it's not an uncanny valley, but it's kind of something that feels something that you know, but at the same time you see that it follows its own logic. And at the same time, you have this very high precision in front, but then when you look at the back of the robot, it looks all a bit more arbitrary, because it's a system you do not fully understand. Of course, you can relate to it in an intuitive level because our own arms work like that as well, but it's kind of not this one-to-one translation that makes it completely clear what the robot is doing in the back in order to kind of draw something very precise, for example, in front. And I think this is this kind of tension that you have with those machines. They're something you have a relationship with in a certain way, but it still feels kind of off. And I think that makes it exciting.
Yeah, I think it's exciting too. Just watching those videos, I could imagine the story of those creatures almost, and what they were thinking, which is kind of amazing. What we imprint, as we saw with the other dance pieces too, as well, and many of these. I think that leads me on to a question actually for Christoph about the amazing robot theatre. There's a more practical question that someone has asked, but I wanted to ask you a more sort of, maybe a slightly philosophical question. Do these actors refer to themselves as robots? Do they know that in the story, or are they acting as humans? Does that make sense?
Yes, absolutely yes, because one of the tales is Stanisław Lem's Tale of the Robots. There is a story about the queen and the princess and the robot, and the plot is about that this princess fell in love in a human being, and there is a boy, robot boy, who tries to, to take her heart, but he's trying so hard to pretend to be a human, to be likable by her. So the stories in the theater are connected with the robots that maybe or maybe not are trying to be a human being. The other tale is about the quirks of the dimensions, like it's for children to better know that the flat object cannot see object that is four-dimensional. The four-dimensional object can see flat surface as it is, but the flat surface sees only like forward and on the right, left, nothing else. So in fourth dimension, maybe not, there's a being that can see actually us, all of us as a beings of three-dimensional world. So yes, there are some hard topics about this, like in the question.
Brilliant, thank you so much. And then the practical question was, is this installation of the robot theatre limited to this one place, or could it be toured to another venue, for example?
Okay, so actually we have 4 robots. 3 of them are actors, and 1 of them is a greeter at the entrance. When there are children with the parents, and parents are busy buying a ticket, for example, or something else, there is a robot with the control panel from the engineered arts, and they actually can make the poses, make the faces, eyes. They can play some speeches of this robot, some funny jokes this robot can make. It has pre-programmed moves, and so this is like a sandbox. In the theater we have a very good program. Actually, it is a program. It is with every move is tested. It's a good word, because this is a cooperation of 3 robots. In the entrance where the greeter is, you can do whatever you want. You can use this touch screen, this computer which controls it, and play around with the robot thespian.
Great, thank you so much. Now, Claudio, first of all, we've had some comments, really lovely comments, just saying how wonderful and magical your work is. So thank you so much for sharing it with us. I totally agree. Someone is asking where the next shows are, but perhaps you could finish your question by telling us where you will next perform. My question to start with, though, is have you and your company built all of this technical stuff on your own? And how long has it taken for you to develop things from the idea all the way through to creating it? And how much knowledge did your team have on the technical side during that process?
Yes, we all made the things on your own in the house, and we don't have a theater, so we test it in my kitchen, in the garage, and after that we go in the theater and put all our magical tricks on the stage, and we have studied a little bit of electronic and informatics, but we learn new programs because we need to do one magic things in theater, and we learn and we study what we don't know, and so we are in three, and we do all things.
That's really interesting, and I actually would have loved to see all your experiments and what came out of the mistakes and the successes. It's really interesting. And so finally, I suppose, please tell us, when are you next performing? Is there a show coming up that that you are performing?
Yes, we perform in Italy, and next month we are in Milan. We perform in Italy for perhaps next year we can go around Europe.
Of course, it's been a difficult time for moving outside of many different zones. I do understand that. Well, I think actually, as sad as I am to say this, I think that's all the time we have for our panel today. So really, thank you so much. It's been so inspiring to see your work and to see how so many different applications of different technologies, but also robotics, different kind of characters coming out of there, and seeing your experimentation. And thank you for doing this sort of research and development so you can share it with all of us, but also to see your performances. So it's much appreciated, and thank you for your time.